Hello guys, what's up? This is Dave. Today we are going to solve previous year's question papers, okay? Alright, so let us see the first question. Preeti reached the metro station and found that escalator was not working. She walked up the escalator which was stationary, okay? So she's walking up the stationary escalator in time t1. On other days, if she remains stationary on the moving escalator, then the escalator takes her up in time t2. So in the first situation, only Preeti is moving. In the second, only escalator is moving, and we have to find out the time taken when both are moving. When she is walking up and the escalator is also moving, okay? Alright, so these are the three situations. You see, this is the first situation. In this situation, the escalator is stationary, velocity of escalator is 0. And Preeti is going up with a velocity of speed, we can say, which is Vp. And she takes time t1 to reach here, okay? And in the second situation, escalator is moving, while velocity of Preeti is 0, okay? And in the third situation, both are moving, okay? Now we have to find out the time in the third situation. You see, in the first situation, let us assume Preeti travels the distance x, okay? So, when she travels the distance x, she takes a time t1, okay? So, we can say x divided by Vp is t1. In the second situation, when the escalator is moving, Preeti is stationary, she takes a time t2. This means the distance travelled up, which will be x divided by velocity of escalator, okay? Because Preeti is not moving here. This is first situation, this is second situation, and now we come to the third. In the third situation, the distance divided by total velocity of escalator and velocity of Preeti. If an observer is standing over here outside, then this will be the total time t, okay? So this is the situation. Now we have to calculate t, okay? So what was Vp? Vp will be x divided by t1. From here, Ve would be x divided by t2, and so t would be equal to x divided by x by t1 plus x by t2, right? Ve is x by t2, x gets cancelled out, so we are left with t equal to t1 t2 divided by t1 plus t2, okay? Hence this is the answer, okay? So here option 2 is the answer, okay? My answer matches as option 2, t1 t2 by t1 plus t2. So this is the answer, okay? Alright, so let us come to the second question. One end of the string length L is connected to a particle of mass m, and other end is to a small peg on a smooth horizontal table, okay? So you get the figure, there is a smooth horizontal table. At one end there is a peg, okay? And at the other end there is a mass. Both are connected by a string. If the particle moves in a circle with speed v, then the net force on the particle will be. Alright, so here it has been given that T is the tension. Alright, so what will be the net force on the particle? So let's see. Alright, so this is the question. We have the peg over here and the particle over here. Both are connected by a string of length L. Particle is going around a circle with a velocity v. So as I earlier told you, when a particle goes around a circle, so the force on the particle is always directed towards inwards, and it is called a centripetal force, okay? So here this force will be directed towards the peg, okay? The center, we can say O. So this will be the centripetal force, okay? Centripetal force. So this would be equal to mv square by L. I have derived this, okay, in my previous videos. And now you see the tension in the string, if it is T, so it is the tension is responsible for the particle going around a circle. So actually tension is causing the acceleration of the particle. For example, if here was one particle, one planet, and here was the sun, so planet would still go around the sun. Why? Because of gravitation force, okay? So gravitation would be responsible for moving the planet across the circle. This means gravitation would be producing this centripetal force and hence causing the acceleration. Hence, the gravitation force would balance the centripetal force. In this case, it would be Gms m by r square. This would be equal to mv square by r. Okay, but in this case there is no gravitation force, there is a tension balancing. So T would be equal to mv square by L. Okay, so answer is either T or either mv square by L, both can be the answer. Okay, T is equal to mv square by L. Okay, answer is either T or either mv square by L. Okay, but it cannot be T plus. Okay, since tension is responsible for the particle going around the circle. Okay, so answer here would be fourth option, as mv square by L is not given here. T is obviously equal to mv square by L, so T is the answer. T plus mv square by L is not the answer. T minus is also not the answer. 0 cannot be there. Only T is the answer. Okay, move on to the next question. It is given that x and y coordinates of the particle at any time are x equal to 5t minus 2t square and y equal to 10t, where x and y are in meters and t in seconds. Acceleration of particle at t equal to 2 seconds is. Alright, so this is the question. The x coordinate is given as this and y is this. Okay, so first, before calculating acceleration, we can find out the velocity. V is dx over dt. Okay, so this would be 5 minus 4t, and Vx, okay, this is termed as I direction. I is a unit vector along x, and Vy will be 10. Now what will be the acceleration? You see, when we differentiate Vx, this vanishes and this vanishes, so we have minus 4 only, minus 4i meters per second square. Okay, and when we differentiate y, dvy by dt, we have 0. So we see acceleration is 0 in the y direction. Ay is 0, but ax is this. Ax is minus 4i meters per second square. If we take the magnitude, so the total acceleration would be minus 4 meters per second square. Okay, in the x direction. Alright, so option number 2. Option number 2 will be my answer. Okay. Alright, so let's take the next question. Two blocks A and B of masses 3m and m are respectively connected by massless. I told you before, massless and inextensible. Okay. The whole system is suspended by a massless spring shown in the figure. Magnitudes of acceleration of A and B immediately after the string is cut are respectively. Okay, so one thing you can obviously guess here, when this string is cut over here, B will obviously fall without any force applying on it except gravity. So we can guess that B will have the acceleration g. Okay, but there are two options over here, g by 3 and gg. So we can get confused between these two options. So we will have to calculate the acceleration of A also. Otherwise, you could have done it with the acceleration of B only. Okay. So we have the following figure. Let us assume the spring constant to be K. So you see, initially when these blocks are attached, the system must have been stable for some time before the string is cut. So what happens when the system is stable? You see the force on the spring. What will be the force on the spring? When the spring has been applied by a force, then it will revert back. Okay, since some displacement has occurred and then the spring is stationary, this means the spring force will be kx. Okay, according to Hooke's law. But what will be this force? This force will be the combined weight of these two, 3 mg and mg. Okay, so this means F would be equal to kx as spring is massless. Okay, since after some displacement spring has stopped, this means F equal to kx. F would be 4 mg. This would be the combined weight of 3m and m. Okay, this would be kx. Now when the string is cut, you see, when the string is cut, this means the block B will obviously fall with the acceleration g, as there is no force on it, but the block A has force kx on it. Okay, the kx will pull the block A upwards. You see, I am drawing the force on block A, and this would be 3 mg. So kx minus 3 mg would be equal to 3m times A, which is the acceleration of block A. What was kx? Kx was 4 mg. So 4 mg minus 3 mg would be equal to 3 ma, and mm gets cancelled out. 4g minus 3g is g, so g by 3. So the acceleration of A would be g by 3. okay, and acceleration of B would be g. Alright, so here my answer would be 1, okay, as this option matches with my answer, this is the correct option. Alright, so let's see another question. 2 astronauts are floating in gravitational space after having lost contact with their ship, okay. So the two will move towards each other, move away, will be stationary, keep floating. Well, according to me, it should be moved towards each other, because as the astronauts are in the space, there is no force on them except gravitation. So one astronaut will pull the other one in his direction. And this is opposed to when they were on surface. You see, when they were on surface, there was friction to oppose their motion. And there was air friction also. But in space, there is no air, there is no surface. So there is no chance of friction. So they should move towards each other. So I think 1 is the correct option. Okay. Alright, so let's move on to the next question. A spring of force constant K is cut into lengths of ratio 1:2:3. Okay. Then it is written that they are connected in series and a new force constant is K dash. Then they are connected in parallel and force constant is K double dash. So we have to find out the ratio of K dash and K double dash. Okay. Alright, so this is the diagram. So you see there are three lengths L1, L2, L3, and we have L1 is to L2 is to L3. This is equal to 1:2:3. Since we know that the force is constant over here, so since the force is constant, the spring constant will be inversely proportional to the length. Okay. Since we have L1 is to L2 is to L3 as 1:2:3, then we have K1 is to K2 is to K3. Now this would be equal to what? This would be equal to 6:3:2. Alright. Since this K1 is to K2 is to K3 would be equal to 1:2 So we have this LCM as 6:3:2. Okay. Alright. So K1 would be equal to 6K, K2 would be equal to 3K, and K3 would be equal to 2K. Alright. So in series, the displacement matters. Okay. Since in series the displacement matters, this is actually K. Okay. This is not K1. This is K1. This is comma. So in series the displacement matters. This means that F equal to, actually the net displacement X equal to X1 plus X2 plus X3. Okay. Since force is transmitted undiminished as the spring is massless in series. Okay. This is not the case in parallel. Okay. So F by K, X would be F by K, final spring constant. This would be equal to F by K1 plus F by K2 plus F by K3. Okay. F gets cancelled out over here. So we have 1 by K equal to 1 by K1 plus 1 by K2 plus 1 by K3. And this is K dash actually. So what is K1? We take 1 by K outside. 1 by K dash equal to 1 by K, 1 by 6 plus 1 by 3 plus 1 by 2. And LCM is 6, 1 plus 2 plus 3. This would be K. This would be 1. So K dash equal to K. Okay. K dash is equal to K. So K dash was the final spring constant when the springs were connected in series. Now when they are connected in parallel, the forces will be unequally transmitted. Okay. So here will be some other force, here will be some other force, and here will be some other force. So this means the net force F would be equal to F1 plus F2 plus F3. Okay. This would be the net force. So we can straight away assume, and the displacement would be same. Okay. The displacement would be same for all the three springs. Okay. So we can safely assume here K1 plus K2 plus K3 into X. X is the final displacement, since the displacement is same for all the springs when they are connected in parallel. So this final displacement F would be equal to K double dash into X. Since the displacement is same, it cancels out. K1 plus K2 plus K3. K1 was 6K, 6 plus 3 plus 2, 11. So 11K equal to K double dash. Okay. And K dash was K. So K dash divided by K double dash would be equal to 1 by 11. This is the answer. Okay. 1 by 11 is the final answer. Alright. So here option B would be the answer, 1:11. Okay. Alright. So let's move on to the next question. It is given that a rope is wound around a hollow cylindrical cylinder of mass 3 kg and radius 40. What is the angular acceleration of the cylinder if the rope is pulled with a force of 30 newtons? Okay. So you see this is the figure, and let us consider this point as O. So what we have here is that force is pulling the pulley and this is the rope. So when the force pulls the pulley, the force will create a torque. Okay. And that torque would be equal to R cross F, and that torque would be about the point O. So the pulley would be rotating about the point O with an angular acceleration. So torque in that terms, in moment of inertia terms, is known as I alpha. This is a direct formula question. There is no need to think about it. Formula for torque is I times alpha. Alpha actually is the angular acceleration. Okay. So you see torque would be equal to Rf, and this would be equal to I alpha. This would be equal to mr square, and we have to calculate alpha. So Fr, Rr gets cancelled out. So F was 30 newtons divided by M was 3 kg times 0.4 meters. Okay. And if we are to write in alpha, this would be radians per second square. So this goes over here 10, and this would be 100 by 4. So alpha would be equal to 25 radians per second square. Okay. Okay, so option 2 would be my answer over here. Okay, 25 radians per second square. Okay, so let's move on to the next question. This is given as the acceleration due to gravity at a height 1 kilometer above the earth is same as the depth d below the surface of the earth. Okay, although this seems as a very simple formula putting questions, but I want you to know how we arrive at that solution. It's very simple. Above the earth, this would be 1 minus something like 2d by r, and below the earth it would be 1 minus d something by r, whatever. Okay, but how do we arrive at this formula? I'll tell you now. Alright, so consider this. This is the earth and this is the particle. Okay, something of mass m, and this the earth is mass me. Okay, the particle is at a height h from the surface of the earth. Okay, now what will be the force of gravitation? You see, force would be equal to Gmm, this would be me by Re plus h whole square. Okay, this would be the force. So we now do a little manipulation over here. You see Gmem by, I am taking Re out. So we have Re square 1 plus h by Re whole square. Okay, I can write this because when it goes inside, this would be, if I take Re square out, yeah, so 2 will be there and it will be in the bracket Re plus Re into h by Re. Okay, so we can write this. You see, the acceleration due to gravity G is written as Gme by Re square. This we all know. Okay, this we all know. So I am taking this term here and writing it as G. Okay, so F would be equal to G times M by 1 plus h by Re whole square. Okay, so a force would produce an acceleration. This would be equal to mass m times a, gets cancelled. So acceleration above the height h would be equal to G times, I am taking this expression up, we have 1 plus h by Re minus 2. Okay, so we apply binomial theorem in this expression. This is the final expression for A. Okay, so we have A equals G times, this 2 would come here, minus 2 would come here, so 1 minus 2h by Re. Okay, this is the final expression for acceleration. Okay, acceleration of an object which is above the surface of the earth at a height h. Okay, so what happens when the object is below? For example, when the object is below the surface of the earth, for example, this is d. So what happens? For example, this is the object. In general, what happens is that the density of earth comes into play over here. Okay, since earth is a solid, so we assume density as rho. Okay, so rho is mass of the earth divided by 4 by 3 pi Re cube. Okay, So when the particle is over here, the effective distance, let us say the effective distance between the particle and the earth is r. Okay, so this is the whole effective mass. Okay, the outer surface mass will not be counted as particle has gone down. So the effective gravitational force F would be equal to rho times, okay, this would be rho times the volume 4 by 3 pi r cube times the mass m by g, this would be m. This is the effective mass, okay, rho times 4 by 3 pi small r cube. This is a small r because this is the effective mass which is applying force on the particle, okay. We can neglect the outer mass, divided by r square. So g m by r square, okay. So this cancels out. So we have F equal to g rho 4 by 3 pi m r, okay. G rho 4 by 3 pi m and r square is cancelled, okay. So we now what we do is we add here r e cube, okay. So we would have to multiply by r e cube, right. So this 4 by 3 pi r e cube times rho would be mass of earth, okay. So gme, we have taken this 4 by 3 and pi rho and r e cube, okay. So this is mass of the earth times m. What is r over here? Since this is the radius of the earth and this is the distance d, r would be equal to re minus d, okay. This is req and this is the force. Force is mass times acceleration, so mm gets cancelled out. Alright, so we take gme by re square times 1 minus d by re, okay. Re square times re, okay. We can take this as the acceleration due to gravity, so a would be equal to g times 1 minus d by re. So this is the expression of acceleration due to gravity when the object is at a depth d from the surface of the earth, okay. Whereas in the other case it was a equal to g into 1 minus 2h by re. So guys, this was my analysis. Hope you liked the video. Please subscribe, rate, review, recommend and share. Right. Thank you.